All right, let's take a look at number 27 in section 8.2. We have a quadratic function given in non-standard form, and the first thing we want to do is find the vertex. So the formula for finding the first coordinate of the vertex, which we call h, is minus b over 2a. And again, a is the coefficient of x squared, b is the coefficient of x, c is the constant. So we want to do this calculation. Minus negative 14 over 2 times negative 7 is 14 over negative 14, which is negative 1. So the first coordinate of our vertex is negative 1. Once we find h, k is the function evaluated at h, which in this case is f of negative 1, which is negative 7 times the square of negative 1 minus 14 times negative 1 plus 2. So this is negative 7 plus 14 plus 2, which equals 9. So the vertex is the point negative 1, 9. Next, we want to determine whether the parabola opens up or down. We see that a is negative 7. Since that's less than 0, we know that the parabola opens down. Then we want the equation of the axis of symmetry. And that's always x equal to h. So in this case, this is x equal negative 1. Next, we want to find any x-intercepts. So that involves setting the function equal to 0. So negative x squared minus 14x plus 2 equals 0. And we already know the values of a, b, and c. So let's start by looking at the quadratic formula. X equals negative b, negative 14, negative 14, plus or minus the square root of b squared minus 4 times negative 7 times 2, all over 2 times negative 7. So this is x equals 14 plus or minus so this is plus or minus the square root of 252 divided by negative 14. So this is 14 plus or minus I want to point out that you do need to be careful with that negative sign. If you move it to the top, you not only multiply the 7 by a negative, but the negative 3 square root 7 gets multiplied by a negative. So taking this negative sign and multiplying it by the numerator requires that I multiply both terms in the numerator by that. Similarly, in this second expression, if I move that negative sign to the top, I not only multiply the 7 by the negative, but I also multiply the positive 3 square root 7 by the negative. Okay, so I just have to be a little bit careful with negative signs. So this is the result here, and this result is here. Alright, and let's use the calculator to approximate these values. And I only need to round these to the nearest tenth, just to get an idea of where to put them on the graph. So this result is negative 2.1, and this is approximately 0.1. So those are my x-intercepts. When the quadratic function is given in the form f of x equals ax squared plus bx plus c, c is always the y-intercept. So when we go to look for the y-intercept, which is part E of the problem, then the y-intercept is simply the y value 2. C is 2. Okay, so we want to graph this, and the vertex is negative 1, 9. Parabola opens downward. Negative 2.1 is one of my x-intercepts. 0.1 is the other one. My y-intercept is 2. So the graph very roughly looks like this. And, of course, those are nice and smooth. I'm having trouble with this electronic pen drawing that. And let's give the domain and the range. So that's F, the graph. And then G, I want the domain and range. Now the domain for all quadratic functions is all of the real numbers. So the set of all real numbers is the domain. So that's the interval from negative infinity to positive infinity. Since it opens downward, the y value of the vertex is the largest y. So we're going from negative infinity to 9, including that 9 for our range. So this is our problem. And let's take a minute and look at the graphical choices given for this problem in my math lab. Okay, and we can see that D is the choice for this one that allows us to line up with the rough draft of the graph that we did. So D is the correct choice. Opens downward, is left of the origin, the vertex is left and above the origin, and this would complete the problem.